Good morning, third grade. I hope you've had a great morning. We are continuing with lesson 30 on math today. And I know some of you were confused about following along. I'm actually teaching you from the teacher's manual book. So I'm doing the instruction part. And then that's why you take the quiz after you watch the video. And then you guys can do your lesson 30 in your workbook that you have, which is your homework problems. That's why if you don't find this page, that's okay. That's the reason why. Because I'm teaching from the teacher part. You are working from the student book. So, all right, let's get started. So our lesson 30, we started yesterday, and it was talking about perimeter, but they wanted us to use perimeter to find like different kinds of shapes, and they wanted us to find like the missing sides, all of that. Today, they're talking about the same area, but different perimeter. So the reason why this is, you'll see once we do a couple problems, but not always is the perimeter the same as the area. Perimeter is what's on the outside, area is what's on the inside. So we have to look at a couple problems to realize how to figure that out. Okay, it says read the problem below, then explore different ways to find rectangles with the same area and different perimeters. So Emma drew this rectangle at the right. So they're talking about this one. What other rectangles have the same area but different perimeters? So they want us to look down here. It shows, and I even drew my own before we got on. It shows this rectangle and this rectangle. Now, if we count them, we know that the top has, let's count. Can you see this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we know it has 16 square units. Now, let's go back up here. Let's look at this one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Does this one have the same amount of square units as this one? Yes, it does. Now we have this rectangle. Let's look at it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Does that have the same amount of square units as her rectangle up top? Yes, it does. Okay, so we know that they are all square units, 16 square units. But that is the area of them because it's the total amount of square units inside of the perimeter. Now, since you can also turn these on the side and do it this way. Well, now we need to figure out, is it a different perimeter than the area? If we have 16 square units as our area, what is our perimeter going to be? So we need to look at this. Okay, so if we look at this, it's only one box by how many? 16. Great. This one is 2, and it has 8, right? So if it's 2 wide, 8 long, and we know that our perimeter, or we know that our area is 16, but our perimeter, they need to only know just the outside of the shape. So we know this side is 8, so this side has to be 8. We know this side is 2, so we know this side has 2. So let's add them. 8 plus 8 is 16, plus 2 is 18, plus 2 is 20. So our perimeter equals 20 here. Now up here, it's only 1 by 16. So we know this side is the same because there's no other boxes up there. It's just 16. So we know it's 16. So do they have the same area but different perimeters? They do. Let's look up here at her box, or her rectangle she drew. We know that this side is 1, 2, 3, 4. We know this side is 1, 2, 3, 4. So we have 4 plus 4 is what? 8. Plus 4 is 12, plus 4 is 16. Now this one has the same area and perimeter as this one, but not this one. Okay, so sometimes they'll be the same, sometimes they'll be different. Here it's just showing you how they broke it apart. So this one right here has 1 and then 16 across. So 1 is the width, 16 is, we found out the area was 16. Good. And this, I'm not sure why they circled this. Oh, they're showing you that it still had the same exact amount of area, and the perimeter actually equaled the same as well, which we just did that. Okay, so we'll move past that. Okay, now we need to think. We need to connect it. Look at the picture. How can you tell that the two rectangles shown have the same area as Emma's rectangle? Well, we just did that on our, I'm going to show you the problem on here so I don't have to scroll back up. So we just did that on our whiteboard. We showed that each one had 16 square units. So that is our answer. How can you tell the two rectangles shown have the same area as Emma's rectangle? Well, it's because they all have 16 square units. So to find other rectangles with an area of 16 square units, think of multiplication facts with a product of 16. What are the multiplication facts that have a product of 16? Well, let's think. So we know that, let's see, 2 times 8, right? We know 16 times 1, because anything times 1 is itself. We know that's it. Are we done? Am I missing something? You can also do 8 times 2, but that's still the same as 2 times 8. 3, no. 4 times 4. And I think that's it. That's all we got. So I missed 4 times 4. Silly Miss Barker. Okay, so now we know all of those facts. Look at the table and model it. Where do you see the factors and products of the multiplication facts you wrote? Okay, let's look at the table. So we said, if you look at the table really close, gotta get it in the, it is the top one. We said the top one, we said this one, we said the one circled. Yeah, we got them all. So all of these, so the length times the width, if you notice, gives you the area of 16. It's pretty cool. So we know that any of them, so 16 times 1 we said is 16, 8 times 2 we said is 16, 4 times 4 is 16, 2 times 8 is 16, 1 times 16 is 16. We said all of those. Perfect. Okay, so can two rectangles have the same area but different perimeters? Yes, because not all of the areas are going to, not all of the rectangles are going to have a big outside perimeter. Like this one has a very small, this one has a very small perimeter, but it's also, that's the one that has a lot of perimeter units. So anyway, sorry, I got distracted. So we have 1 times 16, so it equals for the area at 16 square units. But when you do the perimeter, it's actually 34. So let's see which one was even. So if we do a square, because it's 4 times 4 times 4 times 4, or 4 plus 4 plus 4 plus 4, you know you get 16. If you are doing 4 times 4, 16. So you're kind of getting the same perimeter, the same area. But that's the only one that has the same perimeter in the same area. Okay, so let's look at, can two rectangles have the same area but have different perimeters? Yes, we agreed with that. Use what you just learned about the area and the perimeter to solve these problems. Show your work on a separate sheet of paper. You can show it on a piece of paper, you can show it in a journal, anything like that. Do what you like, okay? Okay, so let's look at the rectangle below. Draw a rectangle that has the same area but different side lengths. So Draw a rectangle that has the same area, but different side lengths. How can we change this? Well, let's look. Let's see what our area is first. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So we know that we have a total of 18 square units. Okay, so we have 18. What can we change our lengths to? Let's think. So if we know that there's 9 here, we have 2 on the side, so 9 times 2 is 18. How can we change it? Let me try to draw this real quick. Does 3 times 6 equal 18? Sure does. So we still have 18 square units in there. But we're going to try to find if the perimeter is the same. So let's look. Look at the rectangle you drew from problem 12. Is it perimeter the same, greater than, or less than the perimeter of the rectangle shown above? Well, let's look at this one. So we know this side is 9. We know this side is 9. So 9 plus 9 is 18. Plus 2 is 20. Plus 2 is 22. Okay, let's see. Now let's look at ours. 6 plus 6 plus 3 plus 3. So we have 12, 13, 14, 15, 16, 17, 18. Perimeter equals 18. Is it the same? Is it greater than? Or is it less than? If you said less than, you are correct. If you look, I'm going to show you why. Is 6 as long as 9? It's shorter. But you still have a longer side here, but it's still not quite as long as on our problem on number 12. That is why it is less fencing to use, if you want to use fencing as the thing that it's doing. Okay, so we're going to end there for today, just because it saves some time for Monday's lesson as well. We're going to do this on Monday, and we're going to be talking a little bit more about the same perimeter, but different, same perimeter, but different area. And it'll be a little bit different because today's was the same area and different perimeter. And then we'll see how that is. All right, if you would like to work along in your book for lesson 30 in your practice book, let me check the page for you so we can get it. Lesson 30 starts on 321, but 319 parents, it tells you kind of what they're doing and a little introduction so you can help them do their work. So, all right, well, I hope you guys have a great day, and I will see you tomorrow. Bye.